Welcome to the point. In this session, we are discussing about heights and distance. In this topic, there are four basic terms to remember. If we are thorough with these four basic concepts, then we can solve any types of sums regarding heights and distance very easily. First is t ratios or trigonometric ratios. You have to remember the values of these t ratios. Initially remember only the values of sine, and that much is enough to get all other values. Sine theta, sine 0 degree is 0 and sine 30 degree is 1 by 2, sine 45 degree is 1 by root 2 and sine 60 degree is root 3 by 2 and sine 90 degree is 1. If you remember this sine value, then you can easily get all other values I have told before. How will you get it? Cos theta is nothing but write the reverse form of the sine value. That is, cos 0 will be equal to sine 90 degree. That is 1. And cos 30 degree is root 3 by 2. And cos 45 degree is 1 by root 2. And cos 60 degree is 1 by 2. And cos 90 degree is 0. So tan theta. How will you get the value of tan theta? Tan theta is nothing but sin theta by cos theta. That is, the division of these two values gives you the tan theta. That is, tan 0 degree is equals to sin 0 degree by cos 0 degree. That is 0. Similarly, tan 30 degree, that is sin 30 degree by cos 30 degree, that is 1 by root 3. Similarly, solve for all other tan values. We get 1 root 3 and tan 90 degree is not defined. Next, how to find the values of cosecant theta, secant theta and cot theta. Cosecant theta is nothing but it is the reciprocal of sin theta. Similarly, secant theta is the reciprocal of cos theta and cot theta is the reciprocal of tan theta. If you solve these values, you get the values of cosecant, secant and cot theta. The second concept is right angle triangle. To solve any problem, the concept of right angle triangle is very important because the drawings in this mostly end up with a right angle triangle. Let's consider a right angle triangle named ABC. We know that in right angle triangle, one angle is 90 degree and sum of all the angles should be equal to 180 degree. And therefore, if we consider the other angle as a 60 degree and obviously 90 degree plus 60 degree plus x degree is equals to 180 degree. I have written this because I have already told you that sum of all the angles in this triangle should be 180 degree and therefore x is equals to 30 degree and the other angle is 30 degree here. And the longest side in the right angle triangle is called hypotenuse. The side which is to the angle is called adjacent. This is also called as a base. And the left out side here, it is called as a perpendicular or opposite side. Let's write the sides to define the angle. Sin theta is equals to opposite by hypotenuse, which can be also said as perpendicular to hypotenuse. And cos theta is equals to adjacent by hypotenuse. And tan theta is equals to opposite by adjacent. And we know that cosecant theta is nothing but reciprocal of sin theta, which is equals to hypotenuse by opposite. And similarly, secant theta is equals to hypotenuse by adjacent and cot theta is equals to adjacent by opposite. The third topic is angle of elevation. What is this angle of elevation? For example, think a person standing is observing at the top of the tree. While observing the tree, The angle formed between line of sight and the horizontal line, that is the ground level, is called angle of elevation, or simply it can be said as angle of elevation is the angle made by the line of sight of a person to the horizontal. And the last topic is angle of depression. Consider a person standing on his house and observing the object in the ground. So here the horizontal level becomes the level of his eye, and now the line of sight is downwards. So the angle formed between this horizontal line and the line of sight is called angle of depression, or simply it can be said as angle of depression is the angle made by the line of sight of the person with the horizontal is known as angle of depression. This is one of the very basic and important thing you have to know. Consider a right triangle named ABC and let one of the angle be 45 degree, and if the sum of the angle should be 180 degree, and obviously the other angle will also be 45 degree. If this is a case in a right triangle, if any of the angle is 45 degree, then always the opposite side will be equal to the adjacent side. That is, here AB will be equal to BC. So here AB is 6 centimeter and obviously BC is also equals to 6 centimeter. This condition applies only if the angle is 45 degree. Let's start with the problems now. A kite is flying at a height of 45 meter from the level ground. It is attached to a string inclined at an angle of 60 degree to the horizontal, and find the length of the string. So it is given that a kite is flying at a height of 45 meter from the level ground. So the distance from the kite to the ground is 45 meter. It is attached to a string inclined at an angle of 60 degree. It has a string and it is inclined at an angle of 60 degree to the horizontal. So here next we have to find the length of the string here. Now we have the side of opposite, but we have to find the hypotenuse side. So find out in which trigonometric ratios we get both hypotenuse and opposite side. So it is in sin theta, which is equals to opposite by hypotenuse. Here opposite is 45 meter and hypotenuse is, let's say we can take it as x, and now sin theta is nothing but 60 degree. Sin 60 degree is equals to 45 by x. We know the value of sin 60, it is nothing but root 3 by 2, which is equals to 45 by x. Just cross multiply it. Root 3x is equals to 45 into 2. Therefore, we get x is equals to 45 into 2 by root 3. So this 45 we can write, it is a multiple of 3. So we can write it as 15 into 3 into 2 by root 3. And now this 3 can be written as root 3 into root 3 is nothing but 3. So in numerator we take the 3 as root 3 into root 3 into 2 by root 3. Here root 3 get cancels and we are left out with 15 2s are 30 root 3 meter, and this is the length of the string. The same problem can be solved using a trick. So for that trick we need to remember two sets of ratio. Those ratios are 30 degree, 60 degree and 90 degree. This is a right angle triangle we know, and these are the remaining two angles. The ratio of this is 1 is to root 3 is to 2. This is the first set of ratio you have to remember, and the other is 45 degree to 45 degree to 90 degree, which is nothing but 1 is to root 2. This is the second set of ratio. If you remember these two ratios, you can solve the problems very easily. Only if the angles are 60 degree and 90 degree, and 45 degree and 45 degree. If you get other angle than this, then you have to use the usual method which we have solved earlier. So let's solve the problem using this trick method. This is the data we have obtained from the question. Here it is 30 degree, 60 degree and 90 degree. So use this first ratio, that is 30, 60 and 90 degree, which is nothing but 1 is to root 3 is to. For 30 degree, the opposite side will be BC. Let's take it as Y. And for 90 degree, the opposite side will be AB. And let's take it as X. And for 60 degree, the opposite side is AC, which is given as 45 meter. So here we have the value of 60 degree. That is for root 3, it is 45. If for root 3, it is 45, and what is the value for 1? It is nothing but 45 by root 3. And for 90 degree, that is for 2, the value is 2 times of 1, that is 45 into 2 by root 3. Here we have to find the length of the string, that is hypotenuse, that is the opposite side of 90 degree. So the value is 45 into 2 by root 3, which is same as the usual. We get the value as 30 root 3 meter. From a point P on a level ground, the angle of elevation of the top tower is 30 degree. If the tower is 100 meter high, what is the distance of point P from the foot of the tower? The data is given. We can represent it in diagram form. From point P on a level ground, that is point P is on the ground, the angle of elevation of the top tower is 30 degree, and we have a tower and the angle of elevation is 30 degree. The tower is 100 meter high. What is the distance of point P from the foot of the tower? Let the height of tower be AB. So we have to find this distance now. So we know that for right angle triangle, always we have one angle as 90 degree. If the one is 30, the other is obviously 60. If 30, 60, 90, go for the first ratio, that is 30 degree, 60 degree and 90 degree. 30 degrees ratio is 1 is to root 3 is to 2. For 30 degree, we have AB, that is 100 meter. Using this, we can find the other two. We have to find PB now, that is opposite of 60 degree. Opposite of 60 degree is nothing but 100 into root 3, and 2 times of 30 degree is 200 meter. Here we have to find the distance of point P from the foot of the tower. That is nothing but we have to find the length of PB. Length of PB is nothing but opposite of 60 degree. Opposite of 60 degree is 100 root 3. 100 root 3. This is the value, and we know that the value of root 3 is 1.73. Therefore, 100 into 1.73 is nothing but 173 meter is the length of PB. The angle of elevation of a ladder leaning against a wall is 60 degree, and the foot of the ladder is 4.6 meter away from the wall. What is the length of the ladder? Present the data in diagram form. The angle of elevation of the ladder leaning against a wall is 60 degree. This is the ladder and it is 60 degree, and the foot of the ladder is 4.6 meter from the wall. Let's take this as ABC. As the wall is straight, this is a right angle triangle, that is 90 degree, and the other angle is 30 degree. So 30, 60, 90. We can use the ratio of 30, 60 and 90. So we know that for 30 degree is opposite to 4.6 meter, and the ratio of this is 1 is to root 3 is to 2. For 30 degree it is 4.6. We have to find the length of the ladder, that is the hypotenuse. Let's take it as x. X is opposite to 90 degree, and which is 2 times of 30 degree. The 4.6 into 2, is nothing but 9.2. Therefore, x is equals to 9.2 meter is the length of the ladder. Two ships are sailing in the sea on the two sides of a lighthouse. The angle of elevation of the top of the lighthouse is observed from the ships are 30 degree and 45 degree respectively. If the lighthouse is 100-meter high, the distance between the two ships is. So they have said that we have a lighthouse and the two ships are sailing on the two sides of the lighthouse. The angle of elevation of the top of the lighthouse is observed from the ships are 30 degree and 45 degree respectively. If the lighthouse is 100-meter high, the distance between the ships. Consider half of the triangle, that is ACB, and we have 30 degree, 60 degree and 90 degree. The ratios of this are 1 is to root 3 is to 2, and we know that opposite to 30 degree we have 100 meter, that is 30 degree is 100 meter. We have to find the opposite side of 60 degree, that is nothing but 100 into root 3, and opposite of 90 degree is nothing but 200 meter, 200 and 100 root 3. And next we have to find for triangle ABD the distance of BD, that is nothing but we have 45 degree, 45 degree and 90 degree. The ratios are 1 is to root 2. For 45 degree we have the opposite side as 100 meter, and for the other it also remains same. If it is root 2, for 90 degree we have 100 root 2. So here the opposite side of 45 degree, it is measurement is 100 meter. We have to find the distance between the two ships, that is the distance between C and D. Therefore, we have to add C plus D, which is equals to 100 root 3 plus 100, which is equals to take 100 common. So we get root 3 plus 1, and we know that root 3 is nothing but 1.73. So 1.73 plus 1 is nothing but 2.73. 2.73 into 100 is nothing but 273 meter. This is the distance between the two ships. A person sitting on top of the tower, which is 10 meter long, is looking at an object in the ground with an angle of 45 degree. Find the distance of the object from the foot of the tower. Here the angle of depression is 45 degree. So draw the diagram. Assume this as a tower which is 10 meter long. A man is sitting here and he observes an object in the ground which makes 45 degree with the horizontal. The horizontal for this is the eye point. This is line of sight, and we know that these two are parallel to each other, hence we get 45 degree here. And here we have to find the distance of object from the foot of the tower, that is we have to find the distance between BC. Here this is 90 degree and this will be 45 degree. We know that we have seen previously that for 45 degree living hypotenuse adjacent and opposite side will be same. Therefore BC is also 10 meter. Therefore the distance between object from the foot of the tower is 10 meter. The angle of elevation of the sun when the length of the shadow of a tree is root 3 times the height of the tree. It is said that we have a tree and the shadow of it is root 3 times the height of the tree. Let's take the height of the tree as h and its shadow as root 3h. And now this is a line of sight. The angle made here is 0. Here we have the value of opposite and adjacent. So tan theta gives the value of opposite by adjacent, which is equals to h by root 3h. H get cancels and we are left out with 1 by root 3. Tan theta is equals to 1 by root 3 and theta is equals to tan inverse of 1 by root 3. We know that tan 1 by root 3 is nothing but 30 degree. Therefore, theta is equals to 30 degree. The angle of elevation is 30 degree. That's all for this session. Thank you.